Okay, so 9.4. Again, we're going to look at expenses. Yeah, fixed. And, yeah, doesn't help, I can't do that. Variable expenses. So we're starting out here with expenses, right? But so any company is in business to do what? Yes. Make a profit, right? And so money going in and out of a business for the sale of goods and services, going out would be an expense, and coming in would be called what? Revenue, not income yet, so we subtract some things from it, right? But that'd be revenue because, you know, you have some costs of things and you make them, right? And you sell it for a certain price and you get revenue, and hopefully when the revenue is greater than expenses, that's called what? Profit, right? Now any company has a duty, especially if they are public and they've issued stocks, right? The shareholders who now own part of the company, like I mentioned before, any corporation, their primary number one duty is to optimize profit, right? Cash flows in to make their company more valuable and that share of ownership more valuable, right? That's their number. It's a fiduciary duty. They have to do that, right? So one way to do that, we're going to start looking at how we decide, you know, how much to sell something for, how much of a certain thing to make, right? And where, at what like price points they'll start making profits, right? You do revenue minus expense, is that profit, right? And it's a positive number. And when they're equal, it's called break even, okay? Well, let's talk about the two types of expenses, right, that we have to subtract out from all the revenues, right? If we're making widgets or what have you, okay? So you might think, like, if they're manufacturing widgets or calculators, right? They have to purchase certain things to make these, right? Certain materials, you know, plastics and raw materials and whatever it is, the circuit boards, chips and whatnot, right? And that has a cost to it, right? We have to purchase materials to make the item, okay? And be able to sell it for a little bit more, right? So what do you think happens so that as the number of calculators or widgets that they produce increases, what do you think happens to the cost that they have to pay to make them? It will also increase to make more, right? Right? So that's called a variable expense, okay? Variable expense. Variable expenses. Okay? So they change as production increases or decreases. These are expenses that change. Change as production increases or decreases. Okay? So you got like raw materials, right? Maybe what kind of things? Like to make the widgets, raw materials. And if they're running their electronic machines longer to make more, maybe electricity, right? And maybe if you're Amazon, maybe you're not making anything, but the more things you sell, how does Amazon get things to people? And also postage, right, might increase. What? Maybe. So I don't want to complicate it right now. We're assuming we're going to use like the same factory floor that we have, right? I see what you mean, right? That's something we can touch on later. Like that'll happen. That'll be like at some certain point of production, they know they have to produce more. Like after all this is happening, then they have to build another factory to keep up with, right, that kind of thing. So we'll leave that out of it right now. But also, boxes, right, they put out of the postage, they gotta put in the box. Well, the puffy, you know, styrofoam peanuts and whatnot, so packaging might increase. Or even just the package it comes in, right? Everything on the store is in a package you can't open, you know, without a cutting torch, etc., right? All kinds of things that would go into that. So these are variable expenses. They change with the production, with the number of things that get produced up and down, right? Now, there's also fixed expenses in any business. Now, these expenses are what the company would have, whether they produce anything or not. What do you think those kind of things would be? Maybe. The taxes seems like that would be like per unit sold, right, or based on how much they earn. Right? I mean, maybe property taxes or something, certain taxes, right? So, but listen, so fixed expenses are constant, right, regardless of production level. Constant, regardless of production. Okay, so one day they don't make any widgets for that entire day, they still have expenses. What could some of those be? Maybe they don't own the building that they're operating out of, right? Maybe they rent it or lease it, right? They still have to pay that every month, so rent or lease payments, right? That doesn't have any, doesn't make a difference how many widgets you make, right? So I got to pay that every month. Well, other kinds of things, like utilities, maybe water, what?
Labor.
That, okay, that could kind of fall under both, right? It can fall under this or both. We'll talk about that. So maybe certain utilities. What about insurance premiums? They have to pay, right? They have to have all their equipment insured, right? Because a tornado comes through and wipes it out. You got to have that, right? That doesn't change, right? So insurance premiums maybe. Loan payments, yeah, right? Maybe they do own the place, but it's mortgaged out, right? So loan payments, that kind of stuff, right? Now, you mentioned salaries, right? So in some cases that could be fixed, right? Depending on the structure, and depending on how you're paying your employees, right? If you're paying your employees on a straight salary, or they make a certain amount per year, right? Versus like hourly, like at Pudgy's, right? If you make more peaches, they call you in to work longer hours, right? Get paid by the hour, or call more people in to work and add those hours to pay to them, right? And so that would be more of a variable expense, right? But, let's take the school, right? We have a certain number of teachers, and they all have a certain salary they're paid every year, whether we do anything or not. I always do something. But let's say we suddenly get a whole bunch more students, and one class is really big and comes up through. We don't have any more teachers, do we? Right? And maybe we got to put some more hours in to grade all these. Instead of a class of 15, we got classes of 30. Right? That's a lot more work and grading and effort, but I'm not getting paid by the hour. So would that be a fixed or variable expense for the school? Fixed, right? Okay? And lucky them, they're getting more work for the same amount of money, right? There's always different ways to look at things, right? Okay? But at Pudgy's, right? Work more hours, do more work, you get paid more, right? Maybe they got Super Bowls coming up. Instead of, what do you normally get, like a 15-hour week or something like that?
No, I get like 30.
30? Okay. The Super Bowl weekend's big, right? You probably, during that week, there's probably people, 30 might turn to 40, some extra hands on deck, okay? So again, so that's the kind of expense that could kind of fall in either category depending on how it's set up, right? So let's look at some equations for expenses. Now, there's going to be a lot of little equations in it. They're simple, right? But you have to know them and know how to use them. So what I would recommend, well, let's use a note card on all the tests, right? So probably as we go along here, put some of these on your note card. Like right, huh?
We don't have no cards.
Have to shoot note card. Okay. We'll do it after class or something, right? So let's look at some expense. So the total expenses, right? If all expenses are broken up into generally these two categories, the total expense would be what? Added those two added together, right? So we could say that expense E equals variable expenses plus fixed expenses, couldn't we? Right? Variable plus fixed, simple enough. Okay? Now the variable, that would act kind of like a rate of change, wouldn't it? For example, a linear equation. V acts like rate of change, which is what part of the linear equation? M, the slope, right? Okay. And here in just a second, we'll actually make that equation look like mx plus b. But we're not going to use m's and x's and b's, right? Because that, when you guys learned it that way, that's just like in the abstract, generally not attached to any context, right? So with all x's and y's, we're going to use actual letters. So, don't get all twisted up. It's going to be the same as what you already did, but just different letters, okay? So let's take a look, though. Now, the variable cost. Let's look at the V. Think about the V, the variable expenses, right? Like the cost of raw materials to make the calculators, right? So every single calculator that gets made has a cost, a dollar amount attached to it that they have to purchase, right, to make them, right? So let's call that cost for every single calculator C, right? And then maybe the number of calculators they manufacture, like the quantity of them, we could call Q. Yeah? So maybe our variable expenses, the V here, would equal C, the cost to make each one, times what? The number of them that they make. So you use Q, right? I'll go ahead and define these variables, right? So we'll just say C equals cost to make one unit calculator or widget, right? And then we could say Q equals the quantity made. Does that make sense? Right? So overall, the general thing is expenses would be variable plus fixed, okay? And then the variable part of it would be C times Q, okay? Could I combine these two equations? Do we have something equal to something else that we could substitute in? Like in our E equals V plus F? Right? There we go, right? If that's V and it equals that, I can substitute it in. So now we have a slightly more robust. E is going to equal CQ plus F. Does this look a little more like MX plus B? The M in this case is what? Yeah, this looks like Y. I put it right below it. MX plus B, right? So our rate of change is what part of this? Which is what? The cost to make each one, right? And our X is the number that we make. Now what about the B? It's the F, the fixed cost. What is that? Like if you were to graph it. The y-intercept or the starting point. Remember, the fixed costs happen even if that is zero. If Q is zero, we don't make any, we still have all those lease payments, rent payments, right? Okay? That's like the starting point of our expenses. And then the expenses grow with every single widget made by whatever C happens to be, right? So linear equation, you're familiar with it, right? Okay? All right, so that's like the expense side of it. Now, when you sell these things, they sell these widgets or calculators, right? And you pay for them, and that money goes to the company that made them. What's that called? That's revenue. It is the opposite of expense. Okay? That's money received for selling goods and services. Okay? Money received for selling goods and services. And we're going to focus predominantly on goods rather than services, because the services is a little complex, right? It's not an actual unit being produced, right? It's more abstract. Okay? So, revenue, you sell these widgets at a particular price. Where do you want to put a standard price? How about P? And you sell a certain number of them. You want to let stand for the number of these widgets that you sell. Okay, so how about we have another equation? Revenue equals P times Q. Okay? And we'll say that P is the selling price per unit. Price per unit. And then Q is the same as what it was above, right? But, you know, we're assuming that what they make, they sell, right? So up here, Q is the quantity made. And we're going to assume that the quantity made is equal to quantity sold, right? We could get into, but that's not necessarily always true, but let's just assume that for now, okay? So this will be the quantity sold. Okay? We have another equation, right? So let me just make sure we kind of, let's box these so we can spot them and come back, right? That, and this one here, and then we got this guy. After we substituted, and then we have revenue equals price times quantity. Okay? So that's revenue, that's expenses. What's profit, guys? Well, revenue is the money made. What's the difference between that and profit? Huh? That's revenue. Yeah, you keep it. Okay, expenses, right? So isn't it just revenue minus expenses? Okay, we have equations for both of them, don't we? Okay. So profit equals revenue minus expense. Minus expense. All right, so look, we got this then. Profit equals R minus E. Or loss, by the way. Is it always a profit? I should put profit slash loss, but, right? Okay? And so P equals R minus E. Do we have an equation for R up here that could potentially be plugged in here? Yeah. Do we have an expense equation that could be put in there? Maybe subtract them and get a profit equation at some point, right? A little bit later on, okay? What about if revenue and expenses are equal? Anybody know what we call that? Like if the money you spend to produce these things is equal to the money you get in for selling it. Ever made a profit? Taking a loss? It's called break even. Right? That's the break even point. Okay? So break even right? That is when R equals E. Revenue equals expense. Okay? Or another way to rewrite that, right? What if we subtracted E from both sides of this equation? What would it look like if we subtracted E from both sides of this simple little equation here? Well, we'll let the R minus E. Oh, you're going to do negative equals. So let's just do R. R minus E equals what? 0. And so that looks more like a, right? So break even is when profit equals what? Is it 0, okay? Or loss equals 0, right? No profit, no loss. Okay? So either one of those are valid, right? Sometimes if you're setting up a problem and you got to want to do one of these will be easier to start out with than the other. 6.5 dozen the other, right? Okay. All right. So we got a bunch of equations, right? And let's take a look at example 1. See if we can use these things. John, read example 1 there, will you?
Our students have researched all of the potential expenses. The fixed expenses of the system. The labor and chief has each pair of indications improves the process of it is an overall expense as a function of the quantity.
Fixed or 17,600, right? Okay. Labor, materials, right? So that would be the cost, right? The C, okay? Oh, 753. So C equals $7.53, right? You with me? And what do they want us to do? Represent the total expenses as a function of the quantity produced. Okay? Well, we know that E equals V plus F, right? We have an F, don't we? All right. But is there a Q in that equation that I just wrote? Is there a Q? They want one in there, right? Because they want us to write it in terms of quantity produced, right? With me? Well, if you remember from back up, maybe we did some substituting. Is there a way to get a Q into this equation? Substitute what? Because V, right? Don't forget, V equals CQ, doesn't it, right? So, do we have a C?
Yes.
Okay, so let's rewrite our expense function. E equals what? 7.53 Q plus what? F. And now we have these specific expenses, right? Variable plus fixed, right? In terms of the quantity produced. Okay? That makes sense. So you see how you have to have those equations ready, right? Know how to sub one into the other, depending on what they're asking for. Simple example there. Okay? So now they have an equation, they can start doing some predictions, right? They can start plugging in, okay, if we decide to produce 10,000 of them, you put a 10,000 in there, see what the expenses are, right? Okay? For 20,000, what are the expenses? Okay? So what does the check say? So read that check there. What's that say? How about I read that?
Widget manufacturer's expense function is E equals $6 Q plus 11,000. What are variable costs for each one of them?
Well, this is pretty simple, right? E equals V plus F, right? And variable cost is the C, so just what's the variable cost per unit here? How many? $6, right? Simple as that. They just wanted you to look at their model, say what's the cost of things each one, right? Everybody still hanging there? All right. So we had these equations, and don't forget, we have to know how to substitute some things in, right? Let's take a look at example 2. Mercedes, do you want to read that? Doesn't Matt Kavetsky, whatever.
The expense function is E equals 1 to the 18 plus 12 pounds. Find the average cost of producing one pair of steer 50,000
So this is an interesting, right? All right, so average cost. Okay? Now, it's not going to be the $1.18, right? Because we have fixed expenses. How do you find an average of anything? You get a total and do what? Divide it by the number of things you have, right? And that would be the average. So they want an average price of producing one pair if they make how many? 50,000. So what do we do with that 50,000? No, that's the Q, quantity, isn't it? Yeah. All right, so in this case, our expense equals $1.18 times the quantity, 50,000, then plus the 12,000. All right, so what is that expense? You put it in your calculator, you just look at the book. I was going to say this. $71,000 to make 50,000 of them. Do we agree? So for all the 50,000 together, it costs $71,000. Right? Well, now what's the average per unit then? What do we do? Take the 71,000, so let's do our average, equals $71,000 divided by 50,000 units. And yeah, whatever your calculator says, you always round it to right to the nearest cent for money, right? So $1.42 per unit if they make 50,000 of them. Okay? That would be $1.42 no matter how many they make. Well, demand is going to set the price. That's $1.18. So if you investigate and find that there's a different demand, then $1.18 in the equation will change, right? Well, let's say it's always $1.18 per unit and the fixed 12,000. What if we made, say, I don't know, 100,000 units? Would it be the same average? Why not? It's still $1.18 to make one. What would keep it from not being the same average? The fixed cost. Yes. So we're about to embark, and the book isn't doing this. I'm going to change the check, okay? Because I want to talk to you. Have you ever heard the phrase economies of scale? You know, when a hot new cell phone first comes out, it's really expensive, and then they start making more and more and more of them. If you buy more and more, what happens to the price? Right? Or a new game system, right? Xbox 360 or whatever, PlayStation, right? When they first came out, they were $500, $600, right? Now they're maybe like $200, right? Because they make more and they're selling more. That's called an economy of scale, right? When you make more. So let's investigate that. I'm going to change the check here real quick, all right? So our check is going to just know it's not in the book. So if you go back to your notes, you don't get confused, right? Not in book. I'm making it up on my own, okay? So here's what I want you to think about. What's the average cost of producing in the same situation? 500,000 hand warmers. I want average cost of producing 500,000 hand warmers. Okay, so we're gonna be dealing with the same equation, right? So you know how to find the total cost of producing a ball, right? We take the 500,000, plug it in for Q, right? And take that result and divide it by 500,000. We'll take a minute and do that and see what the average cost then is. Did we get the total expense yet? 500,000? What is it?
602,000.
Somewhere I have written here. 602,000? Let me double check that real quick. So 1.18 times 500,000 plus 12,000 is 602,000. How about that? $602,000. All right, now let's get our average. So it's 602,000 divided by what? What do you got? Well, how much money? $1.20, right? $1.20 per unit. So, is it more or less than producing 50,000? The cost goes down. Why again? What's happening? What's happening? No. You're still selling at 118. Remember, the demand is going to change to $1.18. We're leaving that in the equation. Assuming the demand is the same.
That's next.
That's next. So are the fixed expenses, which don't change, are they not getting like washed out? Like, does that make sense? So the variable expenses as compared to fixed are getting so much larger. In other words, so the fixed expenses comparably are so much smaller now than they were when you only made 50,000, right? So that is one reason why economies of scale happen, right? You start to kind of dilute the fixed expenses, your rent, mortgage, lease, right, tax, stuff like that, property tax, right? That never changes. Does that make sense? So if you ever wondered why the price of things come down after it's been on the market for a while, that's one big reason. Its fixed costs get diluted. Okay? All right. This is called an economy of scale, by the way. I don't write it down. Let's see here. What is there? I'm going to add a little extend to this. Here's what I want you to do. I want to add to this. This is not in the book either. I forgot I was going to do this. So we'll extend our understanding here, maybe. Again, not in book. All right. Here's what I want you to do. I want you to write a graph of the average cost of producing Q units. Okay? So write and graph function for average cost. Okay? Just Q units, however many of them, right? So Q is going to stay in our equation, isn't it? We write this function. So let's think about it. Our average was expenses, which is what? E, divided by what? Well, average is the total of things, the total expenses divided by Q. Okay. So very simply, E over Q. Well, let's make that E a bit more robust. We have an expense function in the problem, don't we? With an E equal in the problem, example 2. Well, it was more than that. So 1.18 Q plus 12, that's the expense, right? And now divided by Q. So there's our function. You got me with it, right? Now please tell me, nobody's going to tell me that those Q's cancel, right? Sweet God, don't tell me that. They don't cancel. You can't cancel over addition, subtraction, right? If this 12,000 was, then they cancel, right? Can't cancel it like that, okay? Well, let's graph that. Look at the variable on the top and the bottom, okay? Let me put that in our calculator and see what that looks like. Let's see what that looks like. So let's go to our TI, and we'll do like y equals 1.18. So make sure we enter it carefully. So when we enter it in the graphic thing, let's make sure we have parentheses around the top, okay? So what do I do? Close that. Don't want that in there anymore. 3. No. Well, I think I can do it with scratch pad. Yeah, I think you can just do it with scratch pad. You can add graph if you want. All right, so I'm going to use my parentheses. Here, 1.18x plus 12,000. Get outside my parentheses. Divided by x. All right? Probably not going to show up because we have to change our window. Okay? So let's make our graph window like this. So I think I'll have to do x from like 0 to 20,000. So 0, make 0 less than or equal to x less than or equal to 20,000. All right. And then for the y side, between 0 and 75. Yeah, we need to see the graph, right? So let's make that change. You guys know how to do that, right?
No, that's why I zoomed out.
Oh, yeah, no, listen. So, graph, I can't see it, right? So I'm going to hit menu. See number 4, window zoom. 4. And I want none of these. I don't want. We're going to hit window so I can type in what I want, right? So 1, window settings. So X min 0. X max, what did I say? 20,000. Let's go to the Y. So between 0 and 75, right? We got that. So now let's see. Now look, we have it, right? So this is how the average changes, isn't it? Right? So our average cost of producing 1 unit. Look what happens on the bottom axis. Right? As our quantity that we produce increases, what happens to the average cost? It goes down because we're washing away the fixed expenses. Right? They're like, as a percentage of all the expenses, they get smaller and smaller and smaller, right? All right, so we're back here, right? So your graph is just roughly, we won't get too nuts. So this is quantity produced, right? And we'll call this the average axis. As you can see, it kind of looks like this. Okay? And you could do like trace button and see like the coordinates, right? Producing a certain amount, right? Okay? And that is the gist of an economy of scale. It's one of the main reasons the price goes down after a product's been on the market for a while. So you don't necessarily want to go out and jump on that new iPhone 68 or whatever they got now. Or any iPhone, by the way. I don't really like iPhone. We're I want an iPhone. Yeah, it'd be better than us.
No, I know.
iPhone. That's simple. Sorry. that was-
In my defense, I miss my things.
I had a Samsung, so
Okay, all right. Well, you're not all bad then.
yeah.
You do have a redeeming quality that you once owned an Android.
Yep.
Okay, good. You can stay.
I was fine with that.
Good? Well, it's been nice knowing you. All right, let's take a look at example 3. This section's taking kind of long. Maybe we won't get to that third one. All right, I thought I extended that. Example 3. So again, when you go back and like look at your notes and compare it with the book as you're studying for a test, make sure you know that check for that standard.
What did we do yesterday?
Nothing. I was the only one.
No, yes.
Because I
She was
noticed
the only one that showed up and was feeling faint. I determined that it was fruitless to proceed with just one student feeling faint. Oh, I will say, so if that happens again, I will proceed. You will be responsible for the material that none of you showed up for on that day, just like it would happen in college.
I was gonna come and I was gonna make it up until I realized I didn't do anything.
Yes, okay. But again, that won't happen. All right.
I got you.
There are a bunch of typos in example 3.
Really?
Yeah, but anyway, Mercedes, read example 3 if you would, please.
Yes, sir.
Mm-hmm.
Willie's Widgets has created a demand function for its widgets, where Q is the quantity demanded and P is the price of one widget. Its expenses function is E equals $3 Q plus 18,000.
Mm-hmm.
Express the expense functions as a function in terms of
So they have created a demand. Now we're talking, you guys are talking about demand now, right? So they did some studying and analyzed data, right? And were able to generate a function for demand. So Q, the quantity demanded they have, right? So we'll call this QD as a function of unit price, right? As a function of unit price, right? And they probably, maybe they did some surveys, right? They polled people, they've been based on past, sales and demand data for certain prices of things, right? And they generated this demand function. Quantity demanded equals negative 112p times price, right? Plus 4,500. And remember, for a demand function, it makes sense for that rate of change to be negative, right? Because as price increases, what happens to the demand? It goes down. Remember, that's rate of change for demand now. We did that one earlier, okay? Now, they also have an expense function, okay? So then they have expenses as a function of quantity. So expenses as a function of quantity. And we just did that in the last example, right? So that's their E equals 3Q plus 18,000. Equals 3Q, I'm not going to put the .00, 18,000. Okay? They want us to express this expense function in terms of P, price. We'll take a look at our expense function. Is there a price anywhere in there? Is there a P? Is there a place to get one from? They put it in there? What do you think? What do these two equations have in common? The quantity. So could I replace something with something else?
replace Q
With?
above.
Yeah, well, the thing it's equal to up here, right? But I want to, replace it as one whole thing, so I want to put it in like with parentheses, right? Okay, so let's do that substitution. We got that. So this will be our expense as a function of price now. We get, right? So now it's expense as function of price. Okay, let's do that substitution. So E equals 3 P, right? Yep. And don't forget, we got to get the 18,000. Okay? All right, so what we got to do now? We got to distribute through, right? Combine like terms. So we get what? E equals negative 336 P, right? Plus, I think it comes to what? 13,500. Again, don't forget plus the 18,000, right? We're almost there now. We're combine like terms. Yeah, that goes to the 31.5, right? So our expenses in terms of price equals negative $336 times the price of each one plus 31,500. Now, you see what we did there? We've had expense this whole time in terms of like the quantity produced, right? But now we can work out our expenses in terms of what the selling price is. Just by substitution. All the stuff that you've done in algebra till now, well, how about right now? Right? You guys be ready to operate a business. Right? That makes sense, everybody? Okay. Because normally, in its natural state, the expense is in terms of the quantity you produce. But if we put a demand function in, like what kind of quantity would be demanded, you know, we work out that equation, we just substitute in, right? We got our now expenses in terms of the price that we sell it for. So we'll see if you guys understand that. There's a check. It's in the book, all right? So I want you guys to read over that check. It should work a lot like what we just did, okay? We give an expense function, and then they went out and had their accountants and analysts develop a demand function. So we can write that expense now in terms of price. So we have E equals 4Q 78,000. Then they tell us that Q negative 4P equals 3,000. We got it. So we'll just do the substitution real quick here. So then E is going to equal 4 times negative 4P plus 3,000 plus 78,000. And I won't go through all the steps here, right? So it's going to be negative 16P, and what are we at, 90,000? I don't have to go through all those. You guys know how to distribute and combine like terms. Something's going goofy with my smartboard. Sound like a little delay. Okay? I don't have to calibrate this thing, the TV. It doesn't, but the problem is now the computer like delays it, like it's a computer delay problem now.
Is there a reason they switched you? How come you don't
Yeah,
know?
he's not mad at this.
So for example, 4, we're going to take a look now at revenue, which is the money that comes in, right? And from the start of the notes there, you guys remember, do we have an equation for revenue?
Yes.
What is the revenue function?
R equals
P times Q, price, so forth times the quantity you sell, right? P times Q, right? Carly, read this example for Molly's Widget World there, will you?
Wally's Widget World, I like that, created a monthly expense function, E equals 1 times Q plus 4,200. Wally's Widget World plans to sell its widgets to retailers at a wholesale price of $2.50 each. How many widgets must be sold to reach the break-even point?
Okay. So there's a couple ways to do this, right? We can do break even by taking the revenue function and setting it equal to the expense function and solving it, right? Or R minus E equals 0, right? But you guys also know that if you want a solution to two equations, you could graph it, couldn't you? And where do you find the solution when you graph two equations? Where they intersect, right? Okay, so that's another way. I'm pretty sure that's how they do it here. So we'll end up having to use the calculator. Now, one thing in these problems, you notice how they give you the equations for like expense and whatnot. They're given explicitly. Say E equals 1.9 cubed, right? That kind of thing. But they often don't give you the revenue function. But you have to know that revenue is what? Price times quantity, PQ, right? They're not giving it to you, but then they give you enough, right? So let's they want to know the break even, right? So our break even, if you recall, is where revenue equals expense, okay? So we need a revenue equation and an expense equation. They gave us the expense one, right? Okay? So we have, what's the expense equation? Okay, but they did not give us the revenue equation. But we know that revenue equals PQ. So don't let that throw you. They rarely give you the actual revenue function in the problem. But can we get it? Did they give us any part of that? Okay, so what's our revenue function? What's the P? Yeah. Remember, that's the cost to make, right? So the sale price is, what was it? 2.5 Q. Right, so we have them both now. You guys get that, right? You notice they didn't have, this is not in the problem, right? But you can get it because they give you the selling price. It's just PQ, okay? So, I mean, we can solve this, by setting them equal and doing it algebraically, which you also need to know how to do. But let's go ahead and graph this on our calculator. You want to graph it by hand without the calculator? Yeah, then you'll sigh. Okay? But let's use our technology to make life easier.
How would people do this when they did not have this?
Just like I had to do in school, because we did not have those. We did them by hand.
How did
We
you
had
do
to
that here?
be kind of accurate, use graph paper, right? And then like a straight edge to make it accurate and all that, Yeah. Do it by hand.
I don't think that.
You shouldn't, right? There's a lot of things we had to do by hand back then. You guys just, no, that's Google. Okay, so let's put these in our calculator. Graph them. We're gonna have E equals, so instead of Q, we'll use X. All right, bring that up here. I think I want to do, close this one out on, why can't I do that? How did I do that?
I've had my stocks here and the price hasn't changed at all.
Hang on a minute. Need ag grass, right? Okay. What'd you say?
I have my stocks over here and the price hasn't changed at all. How am I supposed to make profit?
What stocks?
Your stocks, Petco.
Oh, you gotta watch the ticker. Believe me, it's not. All right, so let's put the revenue in there. What was that? It was 2.5 Q. 2.5. We'll use X. All right. Go down. Let's put our expense in there. That was 1.1 Q. 1.1 X plus 4,200.
Wait, how do I add another line?
Just arrow down.
Huh?
Or did you already hit enter? Just hit the tab button, it goes back up to it.
Okay, there we go.
Because when you hit the tab button, it goes up to the next blank one.
Yeah.
So you arrow up to get the one you put in, right? Okay. So, in real life applications, if you remember, we're only always working in this first quadrant where everything's positive, right? Okay. So let's change our graphing window so that's the case. So we're going to do a graphing window. So the X from 0 to 5100 probably. So let's do 0 less than or equal to X less than or equal to 5100. And for the Y part of it, we'll go to 10,000, 0 to 10,000. 0 to Y equal to 10,000. And that's a skill you kind of need to pick up, right? Like trying to figure out what window will make things fit and work for you, right? So let's go in and make that change. Remember how to do that.
I remember.
So I'll hit the menu button, forward window zoom, and just straight number 1 window settings. Never mind those other ones right now.
Well,
So that's 0, let's say 5100. And then Y from 0 to 10,000. Right. So now we have them out, right? We got that. You can find them intersect, okay? So a nice part about these calculators is it will do, or you can tell it to find that actually coordinates of the intersection point, okay? Let's go ahead and sketch this graph on our notes. I think so there. Just a rough, we don't need to get nuts about it, but just a rough sketch. Not going to be super accurate. Nope, see, here's a glitch, look at that. Okay, bouncing up and down. All right, so our graph for this is going to kind of look like that, right, and so we'll have, well, I'm just going to put a dollar sign because that axis can be revenue or expense, right? And then down here will be quantity, and then we're out here, we'll call this like out here like 5,000, 5K, maybe, right? And then up here, like 10K. So it would just be. But now we know that the expense. What's the y-intercept of the expense function? Where does it start? Hey, what are the fixed expenses for this thing, for this company? Fixed. Remember? So starting, no matter what happens, 4,200, right? So we'll call that like right about here, maybe a little less than halfway to 10, right? So we'll call that 4,200. And then that graph kind of goes up like this, roughly. And we'll see how close this is, right? Okay. And then the revenue one, of course, that starts at 0, doesn't it? Right? And I think, I don't know. So here's our revenue, and here's our expense graph. Okay? And we need to find out what are the coordinates, the x comma y, or the q comma dollars, right? You guys remember how to do this when you were in algebra, mastering these button pushers? Okay, let's go back to it. So follow along with me. Right? So I want to figure out where's that point. So I'm going to hit menu, right? And I want to analyze the graph, right? So see number 6, analyze graph. Graph. 6. There you go. See intersections number 4. Now what it's going to ask you for is a lower bound. Like where do you want to find the, sometimes intersect more than one, right? So here's our lower bound, right? Here. Okay. So just make sure you're to the left of that thing. And now it's asking for you to just use that little mouse pad. Upper bound, get to the other side of it, right? Like that. And so sometimes these things land on top of each other. Move that out of the way. Does yours look like this?
yes.
3e plus 3. That's that scientific notation. 3e means 3 times 10 to the first. Which is what? We learned scientific notation. Yeah. 3 times 10 to the first, 3 times 10 squared, right? Or 3, that's 3 to the third, right? 3 times 10 to the third power. How many zeros at the end of the 3? So it's 3,000, comma, what?
7,000.
Okay.
I just got that. So,
And I think you could change that and set it, right? Maybe yours has the actual number, 3,000. All right. So this is what I don't know. So whatever. So here, right, we're at about 3,000 produced. Oh, come on. See, glitching away. So this is, we'll just call that 3, it's going to be black, right? 3,000 produced, right? And then how many here? Was it 7,500? Huh? $7,500. And now it's going back to blue. What the heck? All right, so the coordinates of this point are 3,000. I'm not going to put a comma in when I do that, because then it'll look like the comma. You can put commas. What do you mean? Ah,
Yeah?
yeah. Parentheses, 3. Sweet, fancy Moses. This is really,
I was like, no way.
okay. 10, that, 3. Why is this happening? 3,000. Look at, suddenly it's an eraser. I can't. 3,000. Oh my goodness. And it's blue. What? See? All right. I went Mr. Ackland fired. Ugh. Comma 7,500. So fighting through all this, I've almost forgotten exactly what it is we're doing here. Oh.
I like his little angry joke.
So this is a break-even point, right? So how many widgets do we need to produce to break even? In other words, not lose any money. All right, so we need to produce 3,000 to break even. What happens if we produce more than 3,000? We'll start making profit. We're up in here. Like, see, past 3,000, do you notice the revenue graph is higher than the expense? Right? And so what would happen up in there? Profit or loss. So up here, we use black for profit. Anything up here is profit. Right? Is it this thing? This? Profit. Sweet mother of pearl. I'm trying to use appropriate language here. Profit, right? I use black for profit, right? Because usually an accounting black means a net gain or profit. And if you hear somebody's in the red, that means it's a loss. So anything down here, look what revenues are lower than expenses, right? So down in here would be losses if we only sell this many. Okay. All right. So our break even, according to this. So at 3,000 widgets, right? And it's red again. I guess because I choose it. So I guess not. Working. So at 3,000 produced, right? Revenue equals expense. Revenue equals expense. And they both equal $7,500. Okay? Let's just say at. You know I put a T in there. This is lovely. Okay? Yeah, it's not this being so long. All right. That was example 4, right?
don't.
All right, so what if they produce 20, let's look at the check real quick. What if they produce, check. If they produce 2,900, so if Q equals 2,900 produced, are they at a profit or a loss?
They're at profit.
At 2,900?
Oh, no, not a loss.
If our break even is 3,000, right? That would be right in there, okay? And you could even use the trace feature on your calculator, right? So you can just see where it ends up, right? Or something like that, right? We would have a loss, okay? So our expenses, right? We could do this on the calculator. So our expenses for that, I think, come out to 73.90. Right, and our revenue ends up being 72.50. That's a loss. And also, you know, because it's the left of that break even 3,000. Okay? It's like what, about $140 loss. Okay? All right, one more example.
Got it.
This is a long one.
Yeah.
Ah, yes, now we're going to find this. They just did it graphically. Now let's find, this will be simple. Example 5. What do they want us to, same stuff, same setup, right? What do they want us to do now? How? How do they want us to find it now?
Algebraically.
Algebraically, right? We did it graphically. So we need to find where R equals E. All right, so what's our revenue function? 2.5Q needs to equal our expense function, 1.1Q. This is really easy. Plus 4,200. And we're just going to solve this for what? Q. Okay. Well, this is easy. What do we do?
First you subtract 1.12.
For both sides, what's 2.5 minus 1.1? 1.4Q will equal 4,200. So we don't, at this level, we don't put all the little baby steps in, right? We do
I said
minus 1.1Q, minus 1.1Q, and draw a line down from the equal sign.
I still do that.
Well, we don't have to. You're big kids now, all right? You're big kids.
Just for a little bit.
Like at every level of math or science you get to, like you can start taking shortcuts that such that everyone in that group with you knows what you did, right? You want to do the stuff you did in 7th grade. All right, and then we divide by, oh, that's fine. This is organized. It's just not as messy.
Okay.
So when we divide both sides, right, we should get 3,000. Q, same as what we had up there.
I used to get in trouble for not adding a baby step.
That was back when you were first learning it.
I thought it was dumb.
But now,
Now,
like right now, like there's nobody here that doesn't take look at this line here and then look at this line and sit and wonder, how the hell did he get that? I'm baffled. That's what I mean. At this point, you know what happened, right? Every level you climb to academically, there's certain things that most everyone around you knows, and you don't have to show all the little baby steps, all right? Okay? Let's try the check for this, and then, God, let's end it after this. All right? So let's look at the check. What's going on there? Okay. So we want to find where R equals E there. What's R? 7Q needs to equal 5Q plus 60,000. This is so easy. Dylan could do it. What? Oh. Thanks. All right, go ahead and do that. So subtract. Watch that. I don't want to lose anybody here. So 7.2Q equals $60,000. Q equals 30,000. Well, let's get the coordinates though. Okay. Nobody really knows for sure. It's very complicated.
I started
It's beyond the scope of this course. But that's the input, right? That would be like the X. What's the output? What's the Y?
Y equals MX.
What's the revenue? Well, revenue and expense are the same, aren't they? So we take this and we got to plug it into one of the equations. Which one?
Says,
Yeah, in other words, it doesn't matter. Why not pick the easy one, right?
says,
So let's do 7 times 30,000. Don't touch your calculators, I swear to God. What is it?
It is 100,000.
Is that right?
No, it's not.
All right, touch your calculator.
I was
I know, no, 210.
So if we were to graph this, the coordinates of that break even would be 30,000. I'm not going to use the separating commas, right? Because that'll be confusing. Comma, 210,000. 30,000 units are input into that equation, and the output from that equation was 210,000.
sweet.
That was a lot, wasn't it, right? You got a lot of really simple friggin' equations, right? But they're not hard to work with, but what you need to know is like how to work with it. Like what you substitute things that are equal, right? They need something in terms of price. Well, hopefully you got another function that's got a p in it, and you can substitute something in. Yeah, Carly, really mature. Come on, man.